Okay, now I would like to show you how to design the slabs. For the slab, once slabs are initially created, they have several properties relating to reinforcement. This is known as their background reinforcement, which will be placed throughout the whole panel. However, designing the background reinforcement to resist all forces in the slabs will result in excessive reinforcement provision. So, a variety of patches of additional reinforcement are also required. Both the slabs and patches are set to be automatically designed by default. The placement of patches is manual process, so it is important to place appropriately sized patches in the correct location. Patches contain a number of stripes, some of which are set to design the average design forces across their widths, and others simply gather a maximum value. The patches also have a variety of properties allowing you to control options like strip width, bar size, and their spacing. Patches are inserted into the model by first selecting the patch command you want to use, then either left-click on appropriate element or by dragging a window around multiple elements. Okay, now we will design a slab. We start with roof level. Then we go to FE chase down. You can see this 2D I already tell you. Results. These are movement torques, movement Y, MDA torque, MDA. You see, this roof slab is flat slab. Column and slab. Beam is only on external. Therefore, there is high benching here. We cannot put reinforcement the whole panel uniformly. We need to put more reinforcement at here. So we need to do patches. So let's start with roof level. We go to design. We can patch column. Patch. Okay. LX X direction patch size is 4 meter, Y is 4 meter. Surface is top. Auto design. Okay. Wait me a while. Okay. We are doing patch column is on rooftop. So 4 meter column. 4 meter is too big. Okay, let's say 3 meter. 3 meter. Auto design at the top surface, just patch it. There are high movement, hogging movement, and high punching shear area. Okay, all the external column we will not patch. I will tell you why we don't patch. Okay, internal. We are patching on internal column only. Okay, then patching of column then. Now we will patch on beam. You see, there is a column, but there is also a beam. So slab will not touch directly with column. There is a slab is sitting on top of beam. So we no need to patch the column. We need to patch the beam. So patch beam, patch size 2 meter, 1 meter, okay enough, then we will patch. Patch, patch, because the whole slab we don't want uniformly reinforcement uniformly throughout because there is some area have high patching. This one we can patch on beam. Patch on beam. It's a roof level. Okay. Internal column because slab directly sitting on column, that's why we patch by column. This is patch by beam. We have parameter wall, parameter beam. Okay. Now we go to, we have here, still in roof story, we will patch the wall, patch wall. Patch width 2 meter. Internal width and patches. Okay. We have patch. This one is not wall, this is beam. Here, you can see it. This is beam, so we patch on beam. This is wall. Okay, done. We go to lower level. Okay, lower level, we see structural view. These are beam. So slab is sitting on beam, so we will patch by beam. Okay, just patch on beam. Very easy. Patch. If you patch on ground floor, we no need to patch on first to 7th story. It is following. This is patch on beam. Okay, now we have wall. We will patch on wall. You see, because this is void, so it will not shade the inner part. Okay. Okay. Done. We can save also. Saving. Now we can design a slab. Now is under slab, design slabs. This is design slab. Now we can design patches. Design patches. Two step. Slab and patches. Okay. Design, slab, design, patches. We can see review view for slab mat. This is roof level. Roof level status under slab and mat. Under we go to review view. Go to review view. Status whether pass or fail. Now the whole slab is pass. Let's we study first with roof level. The ratio. This is the capacity ratio. This area we using for the patch area, patch on beam 0.9 to 1, blue 0.7 to 0.9% of the capacity, 0.5 to 0.7, 0.0 to 0.5. You can see it. Okay. We go through with roof level first. Now we will see the reinforcement. Slab reinforcement. Okay. Now, this is for roof area. This area, this color here is using H10 175 millimeter square per meter. A11 is we are using mesh. This area we are using A11 rebar mesh. Okay. This is for what? This is slab item bottom bar in H direction. Bottom bar. How about bottom bar in Y direction? This is bottom bar in Y direction. We are using H10 175 and this is bottom bar A11 mesh in this area. How about top bar? Go to top, H direction, H studding 150. Top bar H direction 150 millimeter spacing. Top bar H direction is A11 mesh. Then different area, different bar. Y direction. H studding 150 Y direction. Top bar. This is mesh. These area are using mesh. Can we do the whole slab? Okay, for workers to install reinforcement easily, we can check whether we can uniform the all rebar or not. Let's start with bottom bar in H direction. This one is H10 175. Let's say this area, this area, this area. Can we change to H10 175? See it. Click. Later we see bottom bar one direction still pass or not, we can see. Click this one, change it, change it. H10 175 mm, the whole bottom bar one direction is H10 175. We go and check the status. Okay, pass. Ratio. Okay, there is no red color mean the new river you change is still pass. Go back to slab reinforcement. Bottom bar one direction we have completed. We make it uniform. Bottom bar H direction. Okay, we then extend 175. Let's see top bar. Top bar H direction is A11 mesh and H13 150. If you want to use mesh, you can use or loose bar H13. But you cannot reduce the required cross section area. Okay, top bar in H direction. I don't want to use mesh, so I will come H13 150. I want to change it here. Change, change, change. Or become H13 150. Bottom, oh sorry, top bar one direction. So okay, now we check back status. Still pass, ratio, okay, still okay. So your slab reinforcement, you uniform it out. Even the patch area, we have considered high bending shear, high moment. Okay, how about lower floor? Okay, this is not filled, this is beyond scope. Okay, we will see the ratio. This area is not filled, is means beyond scope. Maybe because of we use one-way slab, we will change it to two-way slab. Click it, click. That's one. Control. Okay, we change back to two-way slab. This one, this one. So let's redesign the design slab again because we change it. Okay, still no problem. Design batches again. Okay, now our roof we have redesigned. So the one we earlier we have modified is disappear in roof level. Now okay, now we will use back to H13 150. We will go to roof level slab again. Top start with bottom bar first, Y direction. I want to use H10 175. Here, 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 here. Bottom bar H direction. Okay, uniform. Top bar we will modify H13 150. H direction top bar. Change it, change it. Top bar Y direction. Okay, H13 1, check the status. Okay, ratio. Okay, no red. Pass. How about ground floor? We want to see ratio. Okay. Slab reinforcement. Okay, from ground floor to 7th story, or maybe ground floor only. Okay, now we will change to bottom bar extraction. We change to H6 is very small. I don't want to use. Then I will use user bar, add new one, H10. Okay, 10 millimeter diameter. Use for H10 200 millimeter. Use. Okay. One direction. We will use H10 200 millimeter. Top bar. Okay. Check H10 200 millimeter. We will use H10 200 millimeter. Everything. If you modify what Tekla Structural Designer give you, you still need to check where it's passed or not. Top bar in extraction. Use H10 200. This one already. Okay. Check the status. Wow. Fail. We go and change to H10 200 millimeter is failed here. So go to reinforcement again. Okay. H10. We will use H10 bottom H first. H10 125 millimeter. H10 125 millimeter. Change it. Bottom bar X. Bottom Y. Change it. Oh. H10 125 millimeter. Change it. H10, then top bar, extraction. We will use H10 125. Top bar, one direction, 125. 125. Change it. You can play for economical until you pass, or you can put more reinforcement, but later you still have to check by your status. Okay. Ratio status. Go back to slab reinforcement. 125. H10 125, we change it. Bottom Y, top Y, top X. Now check the status. Ratio. Oh, sorry, here. Ratio. Roof. Status for slab. Check it. Okay, pass. Ratio. Pass. Pass with our new reinforcement. Top or same. Bottom X. Bottom Y. Okay, H10 125 millimeter spacing. Okay, now you have done the slab. How about other levels? Go to structure, level, 6-story. Go to review view, status. Okay, pass ratio, pass. Reinforcement, okay, because we change to base ground floor, change everything here. Bottom X, bottom Y, H10 1 to 5. Okay, save. Just click save here. Then now you have done designer slab. Thank you.